Welcome back into my YouTube channel. Today we are going to run physics for senior 4, structure of the solar system part B. The solar system architect of the overview. We are going to run about solar center, inner and outer, vast distance. Let's start with the solar center. The solar center, including the sun, our stars surrounded by planets, belt, and the small bodies. Let us continue with inner and outer. Local planets, asteroid belt, gas giant, Kuiper belt, and dwarf planet. Vast distance. Earth is 1 astronomical unit from the sun. Outer edges extend beyond 50 astronomical units. Let us continue asteroid belt, which can be considered as our rocky frontier. What is asteroid belt? Asteroid belt can be defined as a region between Mars and Jupiter that contain millions of rocky and metallic objects. It is formed from leftover material that never became a planet due to Jupiter's strong gravity. The belt is spread out, not crowded, and includes large objects like stars. It helps scientists to study the Earth's solar system. Let us continue with the common features of outer planets. Before I continue with looking about the common features of outer planet, let us take a look about the asteroid belt. Asteroid belt is located between Mars and Jupiter, 2.1 up to 3.3 astronomical from the sun. Asteroid belt also including millions of rocky bodies remnant from our solar system. Asteroid belt also it contains largest objects like Ceres, a dwarf planet, which is approximately equal to 940 kilometers in diameter. We have to keep into our mind that the Jupiter's gravity prevents those rocks from forming a planet. The outer planet, giant of the solar system. What we have to know about the outer planet. What is first of all the outer planet? Outer planets are characterized by the following features. Outer planets are very large in size. We can take an example. The very large planet in our solar system is Jupiter. The outer planets have many moons. We can take an example of Saturn, which has a many moons, which is approximately equal to 18 moons. Is one of the outer planets which have many moons in the solar system. Outer planets also have the ring system. Example, Saturn has many visible and famous rings. Outer planets take a long time to orbit the sun. We can take an example also. Neptune takes about 165 Earth years to rotate around the sun. Let us return back into examples of the planets including into our outer planets: Jupiter, Saturn, Uranus, and Neptune. By starting with Jupiter, is commonly known as the largest planet in the solar system. It is approximately equal to 318 times Earth's mass, forms the Great Red Spot. Saturn is known as the spectral rings made of ice and rock and rock particles. Uranus also is unique to the axis, rotated on this side, green and methane color. Neptune is known as the farthest known planet, intense storm, fastest wind, and something like that. Let us continue with the characteristics of the outer planet. As I have told previously, the outer planet can be defined as massive atmosphere with complex weather. And also all outer planets have ring systems, Saturn's most prominent. We can take an example also. Main moons, Jupiter's Gemini is the largest. So outer planets can be composed mostly for hydrogen, helium, methane, and ammonia ices and strong magnetic fields. Let us continue with Kuiper belt, the solar system's ice age. First of all, we have to know what is Kuiper belt. Kuiper belt is a cold, distant region beyond Neptune that contains ice objects, dwarf planets like Pluto and comets. It is made of leftover materials from early solar system and is important source of comets. So let us continue with the keynote about the Kuiper belt. The Kuiper belt is the downward-shaped region beyond Neptune, which is approximately 30 to 55 astronomical units. Kuiper belt also contains millions of ice bodies left over from the solar system from yesterday. We are able to keep into our mind that Kuiper belt can be defined as a home of dwarf planets like Pluto, Haumea, Makemake, and Liquor. So, Kuiper belt can be named after Gerald Kuiper, first object discovered in 1992. Let us continue with the dwarf planet. First of all, dwarf planet can be defined as a small giant planet. So, dwarf planets can be defined as celestial bodies in the solar system that share some characteristics with the planet but not meet all the criteria to be fully frigid as a planet. We can take an examples: Pluto, Ceres, Eris, Haumea, and Makemake. So, as I told previously, dwarf planet can be defined by IAU. IAU, it is International Astronomical Union, orbits Sun nearly spherical but hasn't cleared its orbit. Let us discuss about some examples of planets classified as dwarf planets by starting with Pluto. Once an identified planet, now Kuiper belt dwarf planet, ice rocky, 2,390 km diameter. Ceres can be known as the largest object in the asteroid belt. It is ice rocky surface, is approximately equal to 940 km in diameter. Eris also is discovered in 2005, is a similar size to Pluto and a highly eccentric orbit beyond the Kuiper belt. Let us continue with some characteristics of dwarf planets. Dwarf planets are considered as smaller than major planets, yet gravity shapes them around. Dwarf planets often have thin atmosphere. We can take examples of Pluto's nitrogen. Dwarf planets' orbits can be highly inclined and eccentric. And also, dwarf planets can be considered have some moon. Pluto's Charon is the nearly half size of it. Let us continue with the summary related to outer planet, dwarf planet, and Kuiper belt. Summary related to solar systems area. We have to keep into our mind that we have inner planet, outer giant, asteroid belt, and Kuiper belt. What we have to keep into our mind about the inner planet. Inner planets are considered as rocky quartz planets. What we have to know about the outer giant planet. Outer giant planets are considered as a planet containing gas and ice. What we have to consider as asteroid belt. In asteroid belt, we have to keep into our mind a rocky frontier. What we have to keep into our mind as Kuiper belt. Kuiper belt can be considered as ice age. Gravity and distance shaping its formation. Exploration missions, Voyager, New Horizons continue to reveal surprises. The solar system is dynamic, telling the story of its origin. The journey continues, exploring our cosmic neighborhood. We have to understand the solar system helps us to grasp the planetary formation. Future missions aim to explore Kuiper belt objects and beyond. Our cosmic neighborhood is full of mystery and discoveries. Keep looking up and learning about the place in the universe. Thank you. See you next time.